All right. So we are going to start section 9.5 today. Section 9.5 will take us all week. It's a very important week for you. Okay? Because there are questions from this week on the final. There are questions from next week on the final. And you're going to be taking the final next week. Okay?
Wait, what?
Oh, yeah. Yeah. Okay?
What?
All right?
Wait, no, wait, hold on. Don't we have 3 weeks left of school?
Okay? So, I will tell you this early today, I will tell you mid today, and I will tell you at the end of today. There is a video tomorrow that you must watch before Wednesday. Okay? If you want to be confused on Wednesday during class, don't watch the video. Okay? If you want to understand Wednesday, Thursday, and what you need to do on the final from this week, you're going to need to watch tomorrow's video. Okay? It might be a little longer. It might be 10 to 15 minutes as opposed to 6 minutes. Okay? But it's well worth it. Take notes on it. Have good times with it. Okay? So, this is a very nice slide to copy down. Okay? Because these are the standard forms, general forms, standard forms, if you will, of the 4 conics that we've been dealing with the last 4 weeks. And we started with parabolas and the 2 different formulas for the 2 different kinds of parabolas. Top ones are up, down, bottom ones, left, right. Then we went on to circles. Okay? And we had the 1 formula for any circle given the center and the radius. Then we went on to an ellipse or ellipsi. And we have this formula for an ellipse. And then last week we ended with hyperbolas. And we have the left-right opening hyperbola on top and the up-down opening hyperbola on the bottom. Okay? Now, you've got this probably spread out, or you have these formulas probably spread out in amongst 4 or 5 different pages in your notebook. It is very important that you copy these down and you have them condensed all in one, because this is what we're going to be doing this week. I'll pause the video here and give you guys a couple of minutes to copy these down. Okay, so we got these all written down. Okay, so our job this week is we are going to be given some random equation. And it's going to be not in this form, or these forms, I should say. Our job this week is to, 1, figure out which of the 4 conics we're dealing with, and 2, then graph it, okay, and find all of the parts. Okay? So, there are 4 different conics. There are 2 easy tells to determine which ones are, and then there's a third one that's a little more involved. Okay? So the easiest of the conics to find is a parabola. And the reason that it's the easiest to find is because a parabola is the only conic where there's only 1 squared variable. Okay? So either x is squared or y is squared. Not both. So that's why it's the easiest one to find. The second easiest one to find is the hyperbola. And the reason that the hyperbola is easy to find is because it's the only one that has subtraction between the 2 squared terms. So it's either going to look like x squared minus y squared, or it's going to look like y squared minus x squared. The other two are circle and ellipse. Now those are a little harder to differentiate. One way, and this is more of a technical book type way, is to get the equation, set it equal to 1. So you got to do some manipulation and division and all this stuff. And we'll get into that, and we'll be able to do that on Wednesday, getting the equation equal to 1. And then you look at the denominators below the x and the y terms. If they're equal, if those two denominators on those two squared terms are equal, it's a circle. If they're different, it's an ellipse. Yeah? Now, there's an even easier way to determine circle and ellipse, and that's simply looking at the coefficients on the squared terms. If the two coefficients on the squared terms are the same, it's a circle. If the two coefficients are different on the squared terms, it's an ellipse. So there's two different ways that you can go about figuring out between the difference if it's a circle or if it's an ellipse. Give you a moment to get that copied down. So this is what I'm talking about. These are 4 different equations of 4 different conics. Okay? What we need to do, and today we're just going to figure out which one is which. Okay? Tomorrow you're going to watch a video about completing the square, because we need to use the completing the square techniques to get these into standard form. Wednesday, we're going to put today and tomorrow's video together, and we're going to put these into standard form and then graph them. Same with Thursday. Okay? So we need to use the techniques that we have. Actually, so before I even get started, make sure you write these all down first. Write them all down first, and then we'll go through. So, based on what we just learned, one of these 4 is a parabola, one of these 4 is a hyperbola, one of these 4 is an ellipse, and one of these 4 is a circle. Okay? You tell me now which one is which. What do you got?
Is C a parabola?
Why?
Because it only has one square term.
Bingo. Okay? So C here is a parabola. Because it only has one squared variable. Okay? And it's right there. What else we got? Miss Gallup.
Is A the hyperbola?
Why?
Because it's the only one with subtraction for the square term.
For the squared term. Yep. Because it's x squared minus y squared. Okay? Be another one. What do you got?
Is B in English?
Why?
I don't know if this is right or not, but so would 4 be a coefficient?
Mm-hmm.
So they have different coefficients for the x and the y squared.
Yep. Because it's got two different coefficients. That leaves what is D? And why? Because it's the last one? Because the coefficients on the squareds are the same, yeah? I'll leave myself more space for coefficients. Oops. I spelled it wrong. Okay? So that's part one. Now, what I'd like to do here the rest of the time is I would like to get back into the coming up with the standard forms of equations, because we're going to need to work with that the rest of the week. So I'm going to give you about 5 minutes right now to write me the equation of the conic section. First off, a circle at that center with that radius, and a parabola with that vertex and that focus.
You try. You try to get like pieces of it.
So this is H, this is K, and the radius is 4. So since it's a circle, from that first slide of how the standard form or the general form, x minus h quantity squared plus y minus k quantity squared equals r squared. So this is going to then be x minus 3 quantity squared plus y minus negative 2, so we're going to write that as y plus 2 quantity squared equals 16. So that's the equation of a circle with center 3 comma negative 2 and a radius of 4. For the remainder, the rest of them, we've got to set up a little sketch, if you will. So if I've got a vertex at negative 2 comma negative 4, that would be somewhere down in that range. If I've got a focus at 4 comma negative 4, that tells me that it is a right opening parabola. A right opening parabola is, oops, let me move this down a little bit. A right opening parabola is y minus k quantity squared equals positive 4p times x minus h. Our vertex would be the h and the k. And p is going to be the distance from the vertex to the focus. In this case, it's 6. Or p is also the distance from the vertex to the directrix. So this equation then would be y minus negative 4 quantity squared equals 4 times p. Well, p is 6, so 4 times p is 24 times the quantity x minus negative 2. So we write it as y plus 4 and x plus 2. Questions on either one of those? No? Okay. With that being said, so find me the two equations of the hyperbola and the ellipse under those two different conditions. So again, you probably want to draw yourself a little sketch. You've got vertices here and here. We've got foci here and here, which means then that the center is going to be the midpoint of those two pairs. So the center is going to be at -1 plus 7 is 6, divided by 2 is 3, comma 5. Or 1 plus 5 is 6, divided by 2 is 2. It's an ellipse, so that means that it's going to be x plus h, x minus h, divided by a squared plus k. Yeah, right. B squared equals 1. So right off the start, we've got x minus 3 quantity squared. We've got y minus 5 quantity squared. And that's equal to 1. Okay. We also know that the distance from the center to the vertices is either A or B. Since this is horizontal, it's going to be A, and that distance is going to be 4. So if A is 4, that would make A squared be 16. We know that the distance from the center to the foci is our C value, and that's going to be 2. In an ellipse, C squared is equal to the absolute value of A squared minus B squared. So C squared is 4. If C is 2, C squared is 4. If A is 4, A squared is 16. We just need to find B squared. So 16 minus what gets me 4? 12. So B squared here is 12. And there is our equation. Yes, ma'am.
Wait, so how did you get 16 again?
4 squared.
Right.
Right here. The distance from the center to our vertex. In this case, it was horizontal, so that's why we went that way. That became tan. Okay? Much the same process for the hyperbola. Again, you're going to want to draw yourself a little sketch. Vertices at 7, -3 and 7, 1. Foci at 7, -6 and 7, 4. So this is an up-down hyperbola. So that would be in the form of y minus k quantity squared all over b squared minus x minus h quantity squared all over a squared equals 1. Center is again going to be in the midpoint of those two different sets. So my center here is going to be at 7, not positive 1, excuse me, negative. Agree? Yeah. We know this distance here is b because it's vertical, and that distance is 2. We know that this distance here is c, and that distance is 5. In a hyperbola, it's c squared equals a squared plus b squared. So c squared is 25. A squared we don't know. B squared is 4. So I get that a squared here is 21. So my equation would be y minus negative 1 quantity squared all over 4 minus x minus 7 quantity squared all over 21 is equal to 1. Agree? Yep. Questions?
I used the other equation.
Which other equation?
Isn't there 2 for this one? No.
This, because everything's aligned up vertically here in my sketch, that means it's an up-down hyperbola,
Oh.
which means it's only that one.
Gotcha.
The other equation is for a left-right hyperbola.
Gotcha.
Okay. So you have a purple worksheet this week. It is worksheet number 33. Okay. Right now, you can do very little with it. But what you all have here as I pass it out, there are 10 problems on the front side. For each of those 10 problems, I would like you to identify what the conic is, which that you can do right now. You can identify what the conic is on all 10 of them. Later on this week, we're going to be making it into standard form. So you can't do any of that yet, but we'll be able to do that starting on Wednesday. So then, on the back side, what I want you to do is I want you to graph one of each of the 4 types of conics. So one graph of a parabola from the front side, one graph of an ellipse from the front side, one graph of a circle from the front side, and one graph of a hyperbola from the front side. You can pick any one of them as long as they're on the front side. Okay? But you get to pick one of each kind.